Cormac McGuinness is the course director for physical sciences and physical moderatorship in Trinity. He received the 2021 Teaching Excellence in Teaching Award, having been screencasting and recording live lectures since 2012, but he introduced lightboards in 2020, which has been a fascinating move.
Okay, so thank you very much for inviting me to be here. I'm going to talk about a lightning talk about how coronavirus has impacted STEM and physics in particular. And so I'm speaking, I'd like to speak first of all about the general legacy of COVID in terms of our teaching. And the fact is that now we're expected, and we've learned how, everybody, to do lecture recording by all. And so pre-pandemic within the School of Physics, 2 lecturers, including myself, were routinely recording screencasts of our live lectures. And so this is some feedback from the 2019 class, where everybody who had written feedback said, well, the online screencasts were incredibly helpful. And it's useful just to reflect back on the usage of those screencasts by the students in semester 2 of 2018-2019 year. And so, they were dipped into throughout the semester, in study week in particular, towards the last lecture earlier before the end of the term, at Easter for some reason, Easter Saturday, and then all of a sudden a huge uptick immediately before the examinations. Okay, well, not very unexpected in that respect. How did physics cope specifically in terms of our adaptations with COVID? Well, laboratories were clearly an issue, and so we had to, the challenge that we were facing was, how could we run the laboratories with only 50% capacity or less than 50%? And so we developed a whole range of online videos, particularly for some of our first year experiments, where we prioritized those experiments where it was less easy to conceptually visualize what was happening than in this case, this kind of a collision momentum experiment with tracks, where you could show the video and provide the data and then get them to use the software tool to analyze the data. But for the experiments that students did in the laboratories, then when they did come in, it would be more challenging things such as oscilloscopes, where to gain practice in using electrical measurement techniques. But in third year laboratories, the experiments were much more complex. So then we had to kind of actually provide a mechanism for students who had to stay away, or later on during the lockdown, this then provided very useful utility in that we had data for a number of our experiments that could be rolled out to all of our students. But one of the other adaptations in our socially distanced third year laboratories, where it wasn't practical to replicate every possible experiment that we would have wanted students to work with, students then worked remotely in pairs. Instead of in pairs at the bench, they would work remotely via webcams and exchange positions from one day to the next at the bench over a 2-day laboratory, and they'd use a shared collaborative notebook, which I'll come back to. But we also developed a number of home experiments for our first year students in particular, with instructions on how to measure the speed of sound. So you can do this with a smartphone and an empty bottle, and so then you can, as well as another variety of home-based measurements. And so we were able to meet the learning outcomes for a lot of our laboratory work. Computational teaching was also very important to us, and so we were able to have some reasonably good material then provided for, in this case, a third year lecture course, a whole physics module on computational physics, where the laboratory component and the training component, having been built on for the previous 2 years, needed more in-depth discussion. Okay, so our problem-solving tutorials were one thing that we developed a whole range of different techniques for. And so here is a speeded up version of 4 different tutorials from 4 different lectures using either iPads or other OneNote or in this case, my case, light boards. So, I mean, to show you a little bit more of the light boards that was alluded to, here is 9 hours of light board tutorials where I am solving problems on this light board that we see here, where I'm writing down with fluorescent markers and describing and answering questions in these live online tutorials with about a dozen students in this case. And so the Lightboard tutorials, it's something that could be talked about later, but it's not something that is easily translated to post-COVID, because now we're doing those same tutorials face-to-face. So one thing that we're definitely bringing forward is the use of collaborative notebooks. So we're going to use class notebooks from OneNote through our Teams environments, where we have shared collaborative spaces, then individual electronic lab notebooks, where then all of a mixed multimedia of the notebook, whether it's videos, screen grabs from software, fits to data, as well as photographs of written derivations, all impact in terms of the laboratory notebooks now we are expecting our students to use, at least from the third year. And so what will be the legacy of what the innovations that we're going to use? Well, some of our virtualized experiments, we're certainly reusing them for this year. We expect to reuse them for reassessment in general. The home physics experiments we are retaining for enhanced learning outcomes, I should read learning outcomes, and then some of the resources for computational teaching we can refer students to. The light boards will remain, but only perhaps as pre-recorded short topics, chunks of materials perhaps that may be refashioned in an asynchronous, synchronous fashion, in the way that Peter Bryant might have described. But the one thing that we're definitely carrying forward is the shared electronic laboratory notebooks, which provides potentially easier means in the future to grade these. Okay, thank you very much.